Hello everyone, welcome to lesson 2.5. This one is on learning what a one-to-one function is. So before we begin learning what it means to be one-to-one, let's talk about and review what it means to be a function. So a relation is a function if each input is related to exactly and only one output. Okay, so if there is in your relation, if there are two inputs that are the same and they go to two different outputs, then it's not a function. But if for some reason it's just listed twice, if it's the same input but it goes to the same output, then that's fine. It's the same point. And graphically, to check if a relation is a function, we use the vertical line test. I will be abbreviating that using capital letters. And with a VLT for vertical line test, so I don't have to keep writing it out. Okay, so that's a quick review. That is from 9th grade year. I'm sorry, I'm sick, by the way, so I keep clearing my throat, and my voice probably sounds different, but bear with me. Okay, so to tell if a function is or is not one-to-one, we use what we call, visually, the horizontal line test. Okay, if you don't have a graph to tell if it's one-to-one, it's kind of the opposite of how to tell if it's a function. To tell if it's a function or not, we look at the inputs and see if there's any that are the same, that go to two different outputs. Well, to tell if it's one-to-one, we look at the outputs. If there are two numbers that are the same in the output column, the y's, then it's not one-to-one because it won't pass the horizontal line test. So if you had something like this, if you had the 0.24 and the 0.34 in a relation, so far it is a function because the inputs are different, but it is now no longer one-to-one because of these outputs being the same. They're both 4. So if you were to graph these, you would notice over 2 up 4, over 3 up 4. This would not pass the horizontal line test because it would hit in more than one spot horizontally. So that's what it means to be one-to-one. So you're looking, first determine if it's a function. So look at the inputs. If it is a function, then to determine if it's one-to-one, you look at the outputs. So here's our first example. Of the 4 tables below, one represents a relationship where y is a one-to-one function of x. Determine which it is and explain why the others are not. So I'm just going to start looking at number 1, and I'm going to first look at the inputs. Well, automatically right away, I notice that there are 2 4s in the inputs, and they go to 2 different outputs. Therefore, it is not even a function, so no, it's also not one-to-one. Okay, so this is not a function because of the 2 inputs being the same going to 2 different outputs. And the 9s also mess it up because there's 2 9s going to 2 different outputs. So that's not even a function. Number 2, if I look at the inputs, looks good. It's a function, right? There's not 2 that are the same. But as soon as I start to look at the outputs now, you'll notice that the first input, -2, goes to 1. And 0 also goes to 1. So because those 2 outputs are the same, it is not one-to-one. And by the way, I'm going to abbreviate one-to-one with a number 1 dash and another number 1. That means one-to-one. It kind of looks like an H, so I'll try to make that a little better. One-to-one. Okay, so that one's not one-to-one. Let's look at number 3. Number 3, no repeating inputs. So far, it looks like a function. And then if I look at the outputs, there are no repeating outputs either. If you were to graph this, it would pass both the vertical and the horizontal line test. So this one is the answer to the question, but we do have to explain why the others are not. So we'd still have to look at number 4. Number 4, if I look at the inputs, you will notice that there are 2 -2s that go to 2 different outputs, 9 and 10. So this one is not only is it not one-to-one, but it's not even a function. Not a function. Okay? All right, and exercise 3, last one. Consider the following 4 graphs which show a relationship between the variables y and x. Circle the 2 graphs that are functions Okay, so remember, to tell if it's a function, we use the vertical line test, the VLT. So if you draw vertical lines anywhere on your graph, remember it has to pass the whole graph. Number 1 does pass. It is a function. Number 2 does not pass. If you draw a vertical line, say here, you could really draw it anywhere. It hits more than once. In fact, my vertical line hits 4 times. So this one's not a function. This one's also not a function. As you can see, it will hit twice. And this one is a function. It will pass the vertical line test. Now it says, of the 2 graphs you circled, which one is 1 to 1? So remember, to tell if it's 1 to 1, you do the horizontal line test. So you are going to, oh, it's not going to let me pick a line. Okay, well, okay, never mind. I'll have to draw it. You're going to draw a horizontal line, and if it fails, which means it hits more than once, then it is not 1 to 1. So you'll notice here's a horizontal line, and it hits more than once. It hits twice. So this one is not 1 to 1. If I do horizontal line test here, it's only ever going to hit my function at 1 point, no matter where I do my horizontal line test. So therefore, this one is the one that is 1 to 1. So it is choice 4 because it passes. And I'm going to use HLT, like I said, to abbreviate the horizontal line test. And you can do that as well on your notes. Okay, so that's it for lesson 2.5. Up next is lesson 2.6. Okay, so 2.6 is titled Inverses. So inverses are a lot of fun, actually. You're going to take a function, and to do the inverse, you are simply going to switch the x with the y. And then to turn it into, normal function notation, you got to get y alone. Now, don't forget, sometimes y is also known as f of x. So it could be written that way as well. It could look like, for example, y equals 2x plus 1. It could also look like f of x equals 2x plus 1. So like in this one, it's pretty obvious. You would switch the x with the y, and then you would get y alone because y would be over here now. But this one looks a little funny. Well, you're literally going to switch x with f of x. But when you do that, it's right here, the notation. F of x now turns into f to the negative 1 of x. So this is an exponent. So that is the notation for inverse. If you see the little negative 1 in the exponent spot next to f, that means it's the inverse, okay? So literally all you do is you switch the x's with the y's, and then if you need to write it, if it's just points, you literally just switch the numbers, x with y. But if you need to write the equation of the function, you then have to get y alone. So for example, if I took this one, I would switch and it would become x equals 2y plus 1. And now to figure out the equation of the inverse, you would get y alone. So you would subtract 1 over to the other side, so it would be x minus 1 equals 2y, and then you would divide everything by 2 to get y alone. So it would be x minus 1 all over 2 equals y. So that would be the equation of this guy's inverse. Okay, so let's do an example. It says if the point negative 3 comma 5 lies on the graph of y equals f of x, then which of the following points must lie on the graph of its inverse? Well, its inverse is all of the points, but you switch the x and the y's. So literally, you're going to just switch the x with the y, so the answer is choice 3. So 5 would be the x, and negative 3 would be the y. Okay? All right, next example, exercise 4. So they gave you a table of values for the simple quadratic function f of x equals x squared. Here it is. It's a parabola. And here's the table of values they gave you. Obviously, there could be more or less, but these are the ones they gave you. So part A says, graph the inverse by switching the ordered pairs. So all you're going to do is you're going to take the x's, and they are going to become the y's. Okay, so I'm going to rewrite the top row into the bottom row. So negative 2, negative 1, 0, 1, and 2. And then I'm going to take the old y's and put them in the new x's. So this will be 4, 1, 0, 1, 4. Make sure you keep, obviously, the old x with its old y. So they still have to be together. Okay, so here's the graph of the x squared function. And now we're going to graph the inverse. Okay, so I'm going to plot the point over 4, 1, 2, 3, 4, down 2. I'm going to plot over 1, down 1, 0, 0, 1, 1, and then 4, 1, 2, 3, 4, 1, 2. So basically, you will notice it has the same shape. The only difference is that it kind of flipped, it turned to the right. Well, if you recall back from geometry, you will also notice, hopefully, that if you draw in the line y equals x, which is the diagonal line through the origin where you go up 1 over 1, up 1 over 1, that's y equals x, up 1 over 1, because the slope is 1. You will notice that this is a reflection over that line. Okay, so each point got reflected, like this point here got reflected over this line and it landed here. Okay, so that's the one thing you should notice. There's two things you should notice about this function's inverse. So the first thing is that it's a reflection over the line y equals x. The second thing you should notice is that the inverse graph, the one we just sketched, is not a function. It will not pass the vertical line test. If I drew a vertical line through this graph that I just graphed, it will not pass the vertical line test, okay? So it's not a function. So with that being said, you're going to look at the last thing written on this page, and I actually have to add something to this because it's not worded very well. It says a function will have an inverse. You need to insert a little phrase right here. It will have an inverse that is a function only if it was 1 to 1 to begin with. So what I had to add on here is that, do you see how the original graph, x squared, right, y equals x squared, it has an inverse. We graphed it. But what it doesn't have is an inverse that's a function. And that is because if you look back at the original graph, y equals x squared, it did not pass the horizontal line test. It was not 1 to 1. So because this graph was not 1 to 1, then the inverse is not a function. Okay? So it will still have an inverse, but its inverse won't be a function. That's what this last sentence was supposed to say. So if your original graph is not 1 to 1, then his inverse won't be a function. Now, if your original graph is 1 to 1, then his inverse will be a function. Okay, hopefully that makes sense. So if the original is not 1 to 1, you can still graph the inverse, but the inverse won't pass the vertical line test. It will not be a function. If the original is 1 to 1, then his inverse will be a function as well. Okay, so that is it for lesson 2.6.